Hey everyone, today we're going to be going over balance guidelines for MKS and USI life support. These are the same tools and guidelines that I use to create all the parts in my own mods. So if your idea is to create a mod that is compatible with USI life support and or MKS, and you want to make sure that your parts are balanced against all the components in the core mod, this is going to be something you want to go ahead and take a look at. Again, there's a lot of stuff here. This took several months to make. A lot of balancing went into this, but I'm pretty happy with the overall result. And we're going to go through an entire example so you understand how all these different pieces work. The most important thing out of the gate is that it is based on a combination of mass and volume. So this will kind of ensure that your parts are properly mass volume balanced against MKS parts. Let's go ahead and start. Anything in green, you can go ahead and modify. This is what feeds the spreadsheet. Anything in yellow, blue, red, do not modify. These are all formulas and calculations, so you don't want to mess with those too much. And we will cover all the pieces here. There's a lot of stuff to kind of cover today. So for our sample today, I'm going to work on a brand new converter for a Tundra 250 module. So we'll start off with our crew capacity. I know this one here fits 2 Kerbals. This in turn affects things like basically the volume and the mass already. I can then put in different resources. This one, for example, has material kits, but you could have any number of resources. Just kind of type them in here. You put the volumes, and these are all in liters, by the way. You'll see how it affects everything else over here. But again, we only have one, just some material kits. So whoops. So we'll leave those be. If you have batteries, this is where you put your EC storage. Again, this goes and accounts for the volume and mass of battery storage. We'll put 1000 EC in this one. The next one's admin modules. So these are special functions. Examples are going to include things like MPL functionality, MKS logistics or EL survey stations, planetary logistics from MKS are all in there. In the case of ground construction workshop functionality, in those cases, I assume that functionality does not count against extra space. It's worked into any assembly plan type module. So we'll leave those out for now. And I do have separate calculations for that later on in the spreadsheet, because this will be a ground construction workshop as well. So the next part then is going to be all your different converters. So converters, a couple of different things. First off, I do have some basic standardizations as far as like drills and what their efficiency should be. Usually it's a 5-to-1 if you're a dirt type drill or a bulk harvester versus a raw harvester. Defaults on yield. Greenhouses are always going to be a 10-to-1 mulch to fertilizer and lossless. Refining is going to be a 5-to-1. Farming a 20 or a 50-to-1. Anything involving supplies, that will usually be a 10-to-1 for your fertilizer versus supply output. Assembly, when you put pieces together, that will generally be lossless with some exceptions. If you want to see detail on this, in the next tab over here, this is my worksheet for every single converter in MKS and life support. So you can kind of see how all the pieces tie together. So if you're building an extension to MKS, for example, you do want to look at this spreadsheet and make sure that your ratios and the materials are all basically the same thing. That way your part works seamlessly with MKS. There's also a volume worksheet for figuring out your part volume. Why you care about this is that this is going to be volume and mass driven. So right now I'm building a Tundra 2.5 module, which means that it should have a volume of 19.64, and its mass should be somewhere between 1.9 and 5.8, but probably more in this middle zone here. So the far left here, this is going to be for things like ISRUs, recyclers, where there's mostly machinery and no crew. If it's crewed, say a hybrid one, you'll probably be up on the scale here for a heavy machinery one, whereas things that are more open, like say farms, are going to be closer to the hybrid minimum. And you should never be below this guy here, which is basically all empty space. So more guidelines than anything else, but it makes sure that the modules do kind of feel right, and they should based on all the formulas in there. So again, we have a working volume right now of 19.64. So we build our first converter, and we're going to go ahead and do a machinery one, I think. And machinery, which is somewhere around here, right here, takes 4 material kits, one specialized part, outputs 5 machinery, so it's going to be a 4 to 1, 5 ratio. So we'll put 4, 1, under outputs, put 5. And the next part here is going to be your efficiency. So if you are using specialization bonuses, so like let's say the stock ones, those range from 25% for a 0-star specialist to 125 for a 5-star. If you're not using any kind of specialized bonus, put these both at 100%. We will use specialists, so these will go ahead and be 25, 125. This does impact the available volume and everything else. Now right now, with this set to a 1, I would have a fairly ridiculous volume. So let's go ahead and bring this down until this basically zeroes back into that 19.6 range. So that's 17. That's too much. That's very, very close. So I'm going to go ahead and roll with the 19 cubic meters. So that'll be fine for this particular example here. If you do use USI's swappable converters function, you have multiple bays, you put that in here, or swappable drill heads, same idea. I will have just one, but if I had 2, that's going to obviously increase the volume that I need. Let's make it 1. The next one here is going to be whether it's a normal module or something that's based in agriculture. The latter would be your greenhouses, your farms, stuff like that. They tend to be more volume intensive by design. But again, this is a factory here, so 100% is perfectly fine. All these calculations result in how much machinery it thinks you have. So if you are not doing this for MKS, don't worry about it. If you are using MKS, machinery is how we are able to launch fairly heavy objects, but with most of their internal stuff removed, then re-outfit them in the field. And this is just a guideline. So we'll start by putting, let's say, 700. What's going to happen here, I have a volume of 19 cubic meters, a total expected mass of 3.885, dry mass 0.954. This is probably be a little off. Well, here's my shell mass. I want the dry mass to be slightly higher than the shell. That's why it's a little gray sign here is there. So we're going to go ahead and basically bring this down until I get this here. So I could do like 550 if I wanted to and get a bit more space out of it if I want to. But yeah, you just make sure that this dry mass is above the shell cost. Okay. So I think I'll stick with just 500. Just easy. This in turn will give me my machinery use, my machinery required for the module, all that stuff I can put into the configuration file. How much EC I should use is also calculated automatically based on the converters. I have similar things for harvesters, which would have efficiencies, your threshold, and show your drill EC use. So again, this works with harvesters, converters, the whole spiel. If I'm doing the swappable bays, which this one will do, it also does show all these pieces here, the specialized parts, material kits, and EC required to go ahead and swap. Though this one might be out of date, I need to go ahead and confirm that one. Let's see, if you're doing USI life support, tons of stuff just for USI LS. The first one here is recyclers. These are all cumulative. So if I have 0.5 for 50%, I add 0.1 for 10% for 60. So you see it right there. If I want to have, say, a 65% recycler, I put 0.05 here. So 65% total, or 82% if it's using water as input. This would be the input per second for water for a water-based converter. And if I have a capacity, let's say 3 kerbals, there's my EC per second to support 3 kerbals. Okay, so that kind of helps you build all the formulas for your recyclers. But this is not a recycler, so I'll go ahead and zero these things out. For habitation bonuses versus habitation multipliers for USI LS. The big thing here is that hab bonuses tend to be very volume intensive, whereas multipliers are much more mass intensive. So there's a little disconnect there, especially if they are swappable. So if I do my, let's say 20 Kerbal months, that hits a certain volume and mass. If I do a multiply of, let's say 5, same thing. I'm just going to hit, for let's say 3 Kerbals here, it'll hit a certain volume and mass as well. If you find out that when you do this, let's say we have our 19 volume module here. I'm going to temporarily clear this out, so we can kind of work with life support for a second. Then we'll come back to this in a little bit. One. There we go. Okay. So we're back to almost an empty module. Make that a 0. There we go. Empty module. So if I build, let's say I know I have 19 cubic meters, so Kerbal months, that could be, let's start with 20. Oh, 19. There. With a mass of 2.35. So if I go back to my previous worksheet for volume, that 2.35 is way down here. Yeah, it's mostly open space. So your living quarters are mostly open space. Very little stuff in there, like your bed, things like that. That kind of makes sense from a volume standpoint. So if I were to put this volume in there, and then I went to do a swap to a habitation module, I want to keep that same volume, right? Let's do it for 3 Kerbals. 2.5. 1.5. 1.6. So I'm kind of in the same ballpark as a 2.4 versus 2.375. The problem though is my volume, I still have 10 cubic meters to kind of work with. So I have this extra km bonus to account for that. So if you have a multi-part or multi-converter part that can swap back and forth, you want to make sure it is properly balanced with all that volume that you're using. You want to have the same mass and volume used for it both in habitation mode as well as multiplier mode. So here I can probably add an additional 10 Kerbal months, or maybe 5 Kerbal months, maybe 1 Kerbal month, 2, right there. So I get 4 Kerbal months and a multiplier of 2.2 for 3 Kerbals is the same as my prior one that had like 19. That keeps the life support parts pretty balanced. Again, this is only relevant for parts that swap back and forth, which is not going to be a lot of them. Generally, you would not have multi-converters on the same one without being swappable. The exception being a multiplier tends to use the spare volume to support this guy right here. Again, just be aware that it exists. Zero all that out again. And other stuff we have is reactors. So if you try and build your own reactor, say I want to have one that does say 30 EC per second. Here's the appropriate volume and mass. That 0.3 volume on a 625 stack would be almost a meter high. So these columns here basically show you for your given volume what does that equate to with a 37525, 125, 625. Kind of help you build out part size if you want to. Yeah, just things to kind of help you out. And that covers most of it. There are some other weird ones. A big thing is colonist and med bays. These are based again on different modules. Again, these here are all basically pre-calculated, multiplied out. So this is going to tell you pretty much like how many supplies per hour they take, colony supplies, EC per second, volume, mass. So again, all pre-calculated for these things here. Med base, same thing. Ground construction, same idea. Here's a module. Here's the cubic meters and roughly what the efficiency should be based on that. These are just kind of guesstimates. So again, pretty easy stuff. Let's see, other notes. Generally, if you're a high efficiency converter, they'll be heavier and bigger. Low efficiency, lighter, smaller. Agriculture is always 3 times the volume. Machinery recyclables do not count towards storage space. The converter covers that already. Admin modules do include the science lab. If you're trying to do sifters because they have no input, treat them as a 50-to-1, so 50 input to 1 output converter to determine volume, EC usage, stuff like that. Load harvesters, same as their sifter, just increase the input and yield a little bit. Let's see, if you don't use machinery, still include the mass. Machinery is not part of your recyclables and are not part of your inputs and outputs, be aware of that. Efficiency parts are going to have the same mass volume ratio as the original parts if you do MKS style efficiency parts, so basically build them as a converter effectively. We already covered the whole life support thing. I think that covers everything on the worksheet. So again, it is complicated, there's a lot of stuff in here, but it ultimately does make for parts that, you know, kind of work together. They're, you know, mass and volume balanced, and let you put you know, big parts, small parts, and everything is, again, nice and balanced against all the core MKS and USILS stuff. If you have questions, go ahead and post in the appropriate thread. Not a problem. And I think that covers it. Again, listen, thanks for listening. Hope it helps you guys out, and peace out.